Good morning, friends. Today I am going to explain you how to design a transformer for a residential apartment or a building or anything. Here, first you have to list out all the load details particular to the building, like light points, ceiling fan point, exhaust fan point, 6 amp sockets, 6 amp socket, 20 amp AC socket, street lights, post op lantern, the pump set, water supply pump set, fire pump, solar water heating system, any geysers if you install in the solar water tank. You have to list out all the load particulars into the all the load particulars. Then you have to list out number of suppose a number of quantities. For light points, how many points? Ceiling fan point, how many points? 6 amp sockets, how many sockets? 6 amps, how many? 20 amps, how many? Street lights, how many? Post op lantern, how many? Pump sets, how many? Solar water heating geysers, how many? So you have to list out total number of equipment connected, and next wattage of each equipment, like now I have listed out 2173 is the number of light points, and I have considered each light point as 40 watts. Similarly, I have written all the wattage of each and every equipment and total number of points in the building. So 2173 into 40 is 86920. So 86920. This is the total load in wattage. I want the total load in kilowatt. It is C divided by 1000. C divided by here 1000. Here you can see is 86920 divided by 1000 is 86.92. Similarly, I have done for all the columns 37.74, 73, so on. Now the total connected load is 614.78. So this is the total connected load in the building. Now adding future load at 10%, I got 61.47. Now the total load is the addition of 614.78 and 61.47. It is 676.258. Now consider the diversity factor is 0.6. So diversity factor is what is you will not on all the lights at a time. So some lights will be on and some lights will be off. Like the ceiling fans and exhaust fans also, it will not be continuously functioning all the time. Suppose example street lights, it will be functioning in the night time, not in the daytime. So all the loads will not function at a time. So that's why, and some lights will suppose now consider this example. This is a 30 kilowatt equipment you are functioning. It will be this is a connected load, but the individual maximum demand will be 25 kilowatt. So this is the connected load. This is the individual maximum demand pertaining to the area. Suppose this is a house. This is the connected load, and this is the individual maximum demand of each house or something. So similarly, there will be a saving. So that's why I have considered 60% of the load. So 60% of 676.258, 405.75. Now for simplicity I have taken 400 kilowatt. Now transformer required is kilowatt divided by power factor, that is 470.58. So power factor at my side I have considered 0.85. You may consider the power factor which is prevailing at your side. It may be 0.8, 0.75, whatever it may be. So the transformer required is 500 kilowatt, 500 kVA. Thank you.